one is basically the linear functions and just everything we know about them, really, how we can model them, different pieces of information go along with them. A lot of this will sound familiar. In fact, some of this is what I just taught in Algebra 2 an hour ago. So that means a year ago for you guys. This is something that, we talked about, but it wasn't even new in Algebra 2. Okay, so a little bit of vocab review. Polynomial functions. Polynomial functions, any function that is a sum and or difference of x values having whole number powers and real number coefficients. Okay? Basically, when we look at multiple terms being added and subtracted together, we're talking polynomials. Now, polynomials, the key is they have to have whole number powers and they have to have real number coefficients. Okay, so those will be the two key pieces, because part of what we're going to do today is we are going to distinguish, is this a polynomial function or is it not a polynomial function? So we do have some names here, and some of these names are going to sound familiar. I'm going to kind of start in the middle because it's what's going to be most familiar to you. Linear function. I'll work my way out from it, but linear function is something of the form f of x equals ax plus b. You guys would probably think y equals mx plus b, right? It is degree 1, meaning it has a highest power of 1. And then, remember, lead coefficient is the number in front of the highest power. So in this representation, it's a. Quadratic function means the highest power is 2. Okay, or in other words, it's degree 2. The representation there is ax squared plus bx plus c. Again, leading coefficient is going to be the number in front of the x squared term, so the a. A cubic function starts with an x cubed term. It's going to have a highest power of 3, so degree 3, leading coefficient a. If we go back here, the constant function, when there is no x, when it's just a number, in that case, your degree is 0, and you still have a leading coefficient of a. And then a special case, this one doesn't come up in algebra, but the 0 function, officially, the 0 function is different from the constant function. It has an undefined degree and no leading coefficient. Okay? Now, these examples here that we're going to look at. First question we're going to ask, is it a polynomial? Okay? If it is a polynomial, you're going to be asked to state the degree and leading coefficient. If it's not a polynomial, you're going to be asked why. Okay, so is it a polynomial? If it is, I want to know the degree and leading coefficient. If not, state why not. Okay, so definition polynomial. Any function is a sum and difference of x values having whole number powers, real number coefficients. So, let's start with, is this a polynomial? So a yes or no question, basically.
Yes.
Braden says yes.
I believe it is.
Yeah.
Agree? Disagree?
Sure, why not?
Okay. It's terms added and subtracted together, yes.
Yes.
Are there whole number powers?
Yes.
3 is a whole number, 1 is a whole number, and then this would be like an x is 0. Real number coefficients? Yeah, we don't have any imaginaries. So yes, this is a polynomial. Okay. If it is a polynomial, you're being asked for the degree and leading coefficient. As I said, I taught this just this morning in Algebra 2. What's the degree?
Would it be 3?
And why 3?
That's the 3.
Biggest power. Now, if you were asked for a word, what word would we use to represent degree 3? It is a cubic function. Looking at the chart up above. And what's my lead coefficient?
4.
4, because it is that number out front of the x cubed. Go for it. Okay, questions on A? Calculator Thief just pops right in. Okay. Although usually it's the male version of the Calculator Thief, not the female version. Okay, B. Same questions. Starting off with, is this a polynomial?
No,
No.
Why not?
because there's a negative 4 as an exponent.
And what's wrong with a negative 4 as an exponent?
Not a whole.
Okay. Whole numbers. What's the definition of a whole number?
1, 2, 3, 4, 5, 6, 7, 8.
Okay. And whole numbers do start at
What?
0. They do include 0. Okay, but 0, 1, 2, 3, 4. Okay, so my powers, can they be negative?
No.
No. So this is not a polynomial. Now, that means I'm not going to ask you degree. I'm not going to ask you lead coefficient. But I am going to ask you why. And that's because the power is not a whole number. So you can either say power is not a whole number, or you could mention the fact that it is a negative, because negative numbers are not whole numbers. Okay, good. Okay. H of x equals the square root of 9x to the fourth plus 16x squared.
No. Yes. Yes. Well, yes. You already said no, Birdie. You keep changing it up. I believe it is, because even if you like simplified it, it'd still be what? 3x squared plus 16x. 4x. Yes. 3x.
But you can't take the square root of terms being added together like that.
Yeah, you can. There's nobody out there saying you can't.
She's the math teacher.
Well, in order to take the square root of this, it would have to factor into two identical pieces.
So
So was I right? No.
I still believe it could be a polynomial.
Good.
It's both. It is.
Okay, so Braden gave his reason of why. Brody, what would be your reason of not?
Yeah, buddy.
Because he wants to be different.
Well,
I feel like there's an imaginary number in here.
What?
I don't see any imaginary number.
Yeah, well, and
9
we
and
thought
16 are both full good
You.
numbers.
I said I already thought it.
Doesn't it do like a plus or minus? No.
No, that'd be more if you're taking the square root in an equation setting. Like if you're solving an equation, taking the square root, then you put a plus or minus sign. How do we, let me rewrite this.
Doesn't it become like 9x squared plus 16x? I mean 16.
What's another way to write a square root?
I don't know.
You square that.
As a power of what?
2.
2 on
The power of negative 2.
No.
In a fraction.
Don't know why I
Like
said
1
that.
over.
Mm-hmm. If this is a square root, it has an index of 2, right? And then this right here is just a power of 1, so this is a power of 1/2. Okay, a square root is the same thing as saying a power of 1/2. Sound familiar a little bit? Okay. Now, why do I throw that in there?
It's a fraction. So
It's a fraction.
it's not a whole
1/2 is not a whole number. Okay. Okay. So this is not a polynomial.
I want to meet the person who disagrees
Okay.
with this rule.
It's not a polynomial. And here's the idea. So, side note, I'm going to erase this, but I know Braden was hard set that it was going to be,
Yeah.
Whoops.
wrong.
that is the square root. Now, listen please. If this is the square root, then it has to be able to multiply by itself to get this? Well, to multiply by itself, you would have to FOIL it. And if you FOIL it, you're going to come up with an outside and inside terms that aren't canceling. Okay? So, that's what I wanted to say there. You can't just take the square root of terms being added and subtracted. Okay? So, ultimately, it's not a polynomial, and same answer as last time, the power is not a whole number. Okay, if you want to put something, you could say the power is a fraction, or the fact that there was a square root. Okay. Are we okay with that one? Whether we agreed or disagreed, can we at least a little bit agree now?
Yeah.
Okay.
Hopefully.
Just not true.
Okay, one more. And again, same question, polynomial or not. Is k of x equals 15x minus 2x to the fourth a polynomial?
I'm gonna say yes. Because it just is.
Because it just is.
Because it's the same thing. Even if you just flip it, it's going to be like minus 2x to the fourth.
Do I have whole number powers?
Yeah.
Yeah. X to the first, x to the fourth. Do I have real number coefficients?
Yeah.
Yeah. Okay. So, if it is a polynomial, then I need to know the degree and the leading coefficient. Thoughts on the degree?
4. 1. I don't know. Just say a random number.
4.
Why is it 4?
Highest.
You have to look at the highest power. This equation is not in what I would call standard form, something I also taught this morning in Algebra 2. It's not in standard form. Standard form is when we rewrite it from highest power to lowest power. Nothing says it has to be in standard form. They're trying to trick you here, right? So it is a degree 4, which, according to our Algebra 2 notes, is a quartic. Okay, I don't know if you guys remember that or not. What's my lead coefficient then?
2.
15. I don't know.
Minus 2.
Let's go with negative 2. It has to be the number, the coefficient of the highest powered term. Okay. Did we pass all the tricks now?
Yeah. I think so.
Okay. Are we good? Okay. In this next section, a little definition about linear functions. A polynomial of degree 1 with a leading coefficient equal to the slope, so f of x equals ax plus b, more commonly known as y equals mx plus b for you. Linear functions, okay? Now, a couple of keys here. When we talk linear specifically when there is a degree of 1, okay? Horizontal lines, they're linear in looks, aren't they? But they don't fall into linear functions because there's no x. It's just a constant number. So horizontal lines are graphs of constant functions, just kind of a little special case there. It's not going to be considered a linear function. Vertical lines, well, they're not functions at all because they don't pass the vertical line test. All linear functions create slant lines, as in angled lines. So not the horizontal lines, not the vertical lines. I know we still use the word lines for those. But all linear functions, if it's a linear function right there, is going to create a slant line, so an angled line. Okay? So, now, this example here, write an equation for the linear function f of x such that f of negative 1 equals 2 and f of 3 equals negative 2. Now, I'm going to argue I'm not going to teach you a darn new thing right here. This is Algebra 1. This isn't even Algebra 2, folks. This is Algebra 1. It just looks a little different. Okay? If I'm asking you to write an equation for a linear function, what form are you probably thinking? Okay, fair enough? What about y equals mx plus b? What do we need?
Yeah. And
Okay, we need a slope and a y-intercept. Do they give me either of those? Of course not. That would be too easy.
can we find the slope from those protected y and x points, and then plug the slope in one of those points back in to get whatever the y-intercept is?
Okay, so let's look at this stuff over here, the confusing stuff. F of negative 1 equals 2. Well, this is normally f of what? X. So what is negative 1? It's an x value. And f of x is the same as saying a y. So if f of x, f of negative 1 equals 2, that is the ordered pair what? Negative 1 comma 2. F of 3 equals negative 2. What's that tell me? The x is 3. The y is negative 2. We have two ordered pairs, yes? This doesn't apply to you guys until possibly next year for some of you. Calc loves to do this. Okay? Calc won't tell you, oh, the point negative 1, 2. They won't tell you that. They'll tell you f of negative 1 equals 2. So it's a good thing to start realizing that this is just a point, guys. That's all that is. Now are we at an Algebra 1 problem? I'm not saying how well we remember how to do it, but we're at an Algebra 1 problem. Okay? So with that in mind, okay, what do we say? Negative 1 comma 2, 3 comma negative 2. How do we find slope? Rise over run. And if I have a graph, I'm going to rise over run. Since I'm looking at ordered pairs, what do we think?
Isn't it like y2 minus y1? Something.
You were good on the top half. Y2 minus Y1 over
I feel like it kept stretching out and then it like,
X2 minus X1.
and then it went this way, that way. I can't remember.
Okay. So the idea, and does it matter which one's your 1s and your 2s?
Yeah, just
No.
the same.
Exactly. Be consistent. So if I say this is X1, Y1, and this is X2, Y2, as long as you're consistent, that's what matters. Okay, so do some math. So the way I set mine up, negative 2 minus 2 over 3 minus negative 1. And what are we getting? Which is? Negative 1. Okay, so we have a slope of negative 1. Now, so we're halfway there. We have our slope. What are options for finding the y-intercept?
Can you plug in negative 1 for m and one of the coordinates for y and x?
Mm-hmm. Yeah. So take your y equals mx plus b. Which point do we want to use?
1 and 8. Negative 1 and 2.
Okay. Technically, does it matter? It does not. Okay, so if I use negative 1 and 2, y equals, so 2 equals mx, so m, negative 1 times x, negative 1 plus b. There's another way I taught this using a point slope form last year also, y minus y1 equals m times x minus x1. I'm not going to worry about that right now, but there is another way I've taught this. So do some math, right? 2 equals 1 plus b. And so b is going to be 1, if I've done my math right. So how do I write my answer?
Y equals negative 1x plus 1.
Okay, y equals negative 1x plus 1. Did I need to write that negative 1x?
Can we just write
You could. And I don't even know why, other than I was listening to what she said, I still don't know why I put it in there because normally I don't. My hand got away from me. Now, officially, I'm going to change one other thing. What did it ask me to write an equation for?
F of x.
F of x. So instead of y equals, I'm going to say f of x equals negative x plus 1. Okay? I'm not saying y equals negative x plus 1 is wrong, but on the flip side, I want you to be recognizing of f of x, right? Okay. Questions there? Okay. Before I flip to the back side, average rate of change. Okay? Average rate of change is a fancy way for saying slope. Okay? So the slope of a linear function, which we just talked about, m equals y2 minus y1 over x2 minus x1, characterizes something called the function's rate of change. Okay? All linear functions' rate of change, the slope is constant because a line has a constant rate of change, right? Its rise of a run is constant. It's constantly going up and over at the same rate. All functions have rate of change based on different values of x. There's an average rate of change for a function, however, given an interval. Okay, so with a linear function, it's always the same. Okay, with a nonlinear function, okay, so some curving function. If we think parabola, for instance, is the slope always the same on a parabola? No. And in fact, depending on where you're at on the parabola, you have positive slopes and negative slopes. Okay? And so you can look at a specific area and get an average rate of change that just represents the slope in that area. Okay? And that leads into a big whole calc idea that, again, that's a topic for next year. But, okay. So there's a little bit about what average rate of change is. When you go to the back, okay, average rate of change for a function, y equals f of x, on the interval between x equals a to x equals b, where a and b are not the same, so you have to have two different endpoints on this interval, is f of b minus f of a over b minus a. Now, I don't know if you're thinking of it this way, but this is very much like saying y minus y over x minus x. Okay, because f of b minus f of a is the y value, one y value minus another y value, over b minus a are your x values. Okay, this is a notation we use because as you look at the examples we're getting ready to do, are these linear equations? No. Okay, so it's not something where the slope is going to be the same the entire graph. So we're going to look at the average rate of change for the specific given interval. Okay, now whether they say between x equals a to x equals b, or they could use interval notation and say on the interval from a to b. Okay, but that's how we're going to find average rate of change. Now, it asks us to compute the average rate of change for each of the following. In order to do this, f of x equals x squared, so that's my function, from x equals negative 2 to x equals 0. What are negative 2 and 0? Those are my what? I heard it. Those are my a and b values. Okay? So we know what we're going to fill in on the bottom, yes. We need to find what we're going to fill in on top, which means we need to find f of a. So we need to find f of -2. And we need to find f of b, which is going to be f of 0. This is kind of our preliminary work. Now, what do you know about f of -2?
X equals
So if f of -2, what am I going to do to find f of -2? If f of x is x squared, then f of -2 is going to be -2 squared. What is -2 squared? 4. Okay. What about f of 0? Big math here. If f of x is x squared, f of 0 is 0 squared, which is 0. So we just found f of -2 to be 4 and f of 0 to be, shocking, 0. I know. Shocking math here. Okay, fill in your formula, folks. In other words, if I'm doing f of b minus f of a, in this scenario, that means I'm doing f of, what was b? Officially, it's f of 0 minus f of -2. That's f of b minus f of a over b minus a. So 0 minus -2. And I'm writing out a lot of extra details right now. Are you going to need all these details when you do it on your own?
Yeah.
Maybe, maybe not. Okay? But what do we say? F of 0 is 0 minus f of -2, 4. Basically, there's the math you're doing. 0 minus 4 over 0 minus -2, which is? Which is what?
2.
-2. You end up with -4 over +2, which works out to be -2. Okay, getting the feel for it? Now, I don't know if I tell you now or I tell you later, when you guys go to do homework. See, this is, example 3 has parts A, B, C, yes? A was a rate of change. B, I'm going to do rate of change again, yes? Just different information. C, same thing. So I think it's 82 in homework. 82 is doing average rate of change, but there's like 10 parts. So you do, they're not, it's not all 10 connected. There's just like 10 different parts here. Okay? I know it goes at least A through I or something. I don't know. So just heads up on that. Now, the thing is, how long did A take us?
Not long.
20 minutes.
Okay, A did not take us 20 minutes. Okay.
How do we shift?
A did not take us long. It would take you even less time if you're doing it on your own, most likely, right? Because I slow us down. Okay, let's try B. We want to look at the average rate of change for f of x equals 3x squared minus 1 from x equals -5 to x equals 3. So they gave me a new function, f of x, and they also gave me new what? A and B? Okay, you can jump right into your setup if you want, or what I'm going to do is I'm going to start off by finding f of -5 and f of 3. Finding those values requires a little more work this time, right? F of -5, what are we going to do? 3 times -5 squared minus 1. Do I need to write out more than that? -5 squared is?
I don't know.
125. Negative 125. Wait, no.
Wait, what?
75, right? Yeah, I'm just gonna stop talking.
25 times
Squared
three
it,
is
it'll be
75.
like, what did it be
Okay.
like?
Negative 5 squared is
25.
25.
I was looking up there. and I looked
25
at
times 3
I looked at
75. minus 1.
74.
Okay. We'll call that the back to school fall break Monday math there.
I'm not answering any questions the rest of the week.
Didn't I just put a... I must have erased it.
No.
Okay. F of 3. Let's see if we can do this one better. 3 times 3 squared minus 1. 3 squared is
9,
times 3
27,
minus 1.
26.
Okay. So, f of negative 5 works out to be 74. F of 3 works out to be 26. You got all of your information, set it up. F of B minus f of A. So officially, I'm going to say f of 3 minus f of negative 5, or you could go ahead and jump and just fill in the numbers, over 3 minus negative 5. So what are we doing? 26 minus 74 over 3 minus negative 5. Ready to write it down, make sure you get it right here. What are we getting? Negative 48 over 8, which then divides out to be
Minus 6.
negative 6. Okay,
And then 26 minus 74 was.
now, in the homework, in problem 82, they just set it up a little bit differently. At the top of the problem, they give you like f of x, g of x, h of x, k of x, j of x. You know, and so they tell you which equation to go grab, right? Okay, that's what they'll tell you what equation to go grab. You go grab that equation. In this case, I just, it's f of x all the way through. On C, we got to talk about these cubes. Okay, I double whammy here. First of all, I gave you a cube, which we have to remember some factoring skills. But then what else did I do?
There's no actual numbers.
There's no actual numbers. My A and B, air quotes there, are A and C. Okay? I know that's a little confusing, but A is A, right? And B is C. Okay, well, let's find our pieces here. Easy. The first part's easy, right? I need to know what's f of A and what's f of C. What's f of A going to be? If f of x is 16x cubed, f of A is
16a cubed.
16a cubed. Don't make it any harder than that. This is the easy part of this problem. Gotta get past the easy part. If f of x is 16x cubed, what's f of c?
16C.
16c cubed. Okay, that was easy peasy. Okay, now, we're going to set this up, and I'm going to jump right in. F of b minus f of a is going to be f of c minus f of a. So what am I putting up here? Yep. 16c cubed minus 16a cubed over, instead of b minus a, I'm going to say c minus a.
Is that it?
No. I said there was a hard part to this problem, right? This would be way too easy. This simplifies.
Do we have to square cube root at the top?
No, you can't just randomly cube root. It's not an equation. So,
This thing where because it's a exponent over an exponent, you can like divide, but it's really subtractive or whatever. So it's like the 16c squared
No.
or whatever. Is that big?
no. Okay, let's start off with there's a GCF on top.
4? 16? 16?
Let's go big. Go big or go home. Wait, no, don't go home. I'm not giving you guys that out on a Monday after
You
fall
already said
break.
we could go home.
Nope. Okay, GCF of 16 leaves me with c cubed minus a cubed all over c minus a. Okay. I taught this year, right?
Right.
I really hope I taught this year and I'm not having to take us back to Algebra 2. Because I know you guys want. Okay. Here's the deal, guys. C cubed minus a cubed factors. It's a difference of cubes.
Oh.
Have we reviewed that this year?
Yes.
I think we reviewed it once, but it would really be great if we were.
Well, you know we're going to review it again, but okay. So this is going to factor into a binomial and a trinomial all over c minus a. Now, okay. I don't really have a good spot to put this, but I'm trying to think what.
You got this, Miss Arch.
Well, I know what it is. It's a matter of what letters do I want to use here.
C.
I should just, oh well, you know what? Okay, here, I may. Okay. In the first parenthesis are the cube roots. What's the cube root of c cubed?
C.
What's the cube root of a cubed?
A.
And what sign is already there?
Minus.
So that's c minus a. Okay, in the trinomial, the first piece is the first cube root squared.
So C squared.
So c squared. The middle piece is the two cube roots multiplied together,
Negative CA.
but the opposite sign.
So plus CA squared.
So I'm going to say plus AC because I'm an alphabetical type person. Okay. The last term is the other cube root squared,
A squared.
and it's always a positive plus a squared. Now, what did I just set up to happen?
You can cross out the CAs.
They're not CAs, they are
C minus A.
C minus A. C minus A can cancel with C minus A. What are we left with?
16 parentheses C squared plus AC plus A squared.
Okay. Factoring cubics. Do I have time? I'm trying to remember, how did we write them out? Like, what letters did I use to write them out previously? And that's where I'm struggling with, what letters did I use them with? Yes.
So with like the AC in the last part and in the answer there, like, is it just AC because it's alphabetical, or could it go CA?
It could go CA. I tend to go alphabetical. And that's generally what you tend to see in math.
I got you.
Okay, so, okay, guys, if you want the side note here. Okay. A cubed plus B cubed, because I do agree with Emily. I do think it was A's and B's originally. Factors into A plus B times A squared minus AB plus B squared. On the same note, A cubed minus B cubed factors
Oh,
into
this was on the pink paper.
A minus B times A squared plus AB plus B squared. Is it on this year's pink paper?
No, but it was on last year's.
Oh, okay. I was like, wait a minute. That means I have taught it if it's on this year's pink paper. Okay, so that's your general form. It's one of those things, guys. I taught it out for 2. If I haven't reviewed it pre-calc yet, here we go today. I reviewed it today. Okay. I feel like we reviewed it in chapter P. I think it came up in chapter P. That's something you're going to need to know. Okay, be familiar with it. It does come up on problem 82. Okay, now, I have one last section to finish tomorrow, yes?
Yeah.
This is kind of a big section. We'll talk about the graphing calculus a little bit, and we'll go from there. Homework will not be due till Wednesday then.
Okay.